Basic matrix concepts? Haven't we seen matrices before? Yes, we have in fact, and we have seen them for a number of things, but not that many. We have used matrices already to provide a simpler notation for a linear system and therefore to solve a linear system in an efficient way. But matrices are used for much more than this, okay? And so in this class, what we're going to do is we're going to generalize the whole concept of a matrix and develop some more jargon. So in a way, this class is not going to have any deep concepts, a lot of terminology, a few more symbols and so on, but very important ones. So no new calculations, but as it is typical for linear algebra, lots more words. And speaking of words, let's start with some formal definitions. We just constructed a matrix by taking a system and doing some things to it and then calling what we ended up with a matrix. But let's give a formal definition. So let's say that an m by n matrix A is an ordered set of m by n numbers, where of course m and n are two whole numbers. So it's something that looks familiar, isn't it? Although right now notice that we're looking at a potentially very large matrix with lots and lots and lots of entries. Okay. The important thing about a matrix, of course, is that it is organized in rows, and notice that the number of rows is the first number that we're going to state when we tell what kind of a matrix it is. And of course, a number of columns. And as we saw before, the order, the position of these of the elements of these matrix matter very much. In the context of linear systems, of course, each row corresponds to an equation, each column corresponds to either a variable or the coefficients of a variable or the constants and so on. So each one of them has a specific meaning, and where it is placed is very much important. Okay? Now, those m and n numbers are also called the size or the dimension of a matrix. And you may start noticing that we're getting very, very close to the notation and the terminology we've used for vectors. One more piece of information is that when we talk about the general entry of a matrix, we just mean any one of its numbers. We're going to denote that with capital A, which is the symbol for the matrix, capital letters in bold, with the subscript ij to indicate that it's in the ith row and jth column, or with the lowercase aij, depending on which notation is going to be more efficient for the purpose that we have in mind. So these general entries are pretty much just the components of what we call the components of a vector. Sometimes we're going to call them the components of the matrix as well, although not very commonly. Usually we're going to prefer the word entry.